geometry. Surface area, volume, lateral area. The only problem with geometry is there's a lot of formulas. So this one says we're not really worried about the formula. We're going to do the algebra part of it, and we're going to solve for the variable. And the indicated variable is b. So that's the one we want to solve for here. There's a couple of things that we can do to get the b isolated. So here's b. What is one thing that we could do to try and get b by itself? And notice it's in parentheses. Peter, what do you think?
I started off by multiplying both sides by 2.
Yeah, let's get rid of that fraction. I did the same exact thing. So multiply both sides by 2 so you don't have the fraction to worry about. Makes sense to get rid of it, take it to the other side. And it's no longer a fraction, so that 1/2 is gone. All right, what else can we do to get b by itself?
Divide by h.
Yeah, we need to get that h out of the problem because it's still, the b is still in parentheses, so we got to divide by h. And now we have a plus b, which we're really close to having b by itself because it looks like we should be able to just take that a to the other side and we get 2a, 2 times the area, divided by the height, minus one of the sides of the base would be equal to the other base. So A and B represent the two bases in the trapezoid. Remember, a trapezoid has a pair of parallel lines, so A and B would represent the two different bases. So now I have B equals 2A over H, and then minus A. And so far, like, everything is correct here. You got B by itself. You solved for the indicated variable. The evil part in this problem is me telling you that I want you to simplify completely. Having two separate fractions is not considered simplified. Combining fractions to get one quantity in a fraction is considered simplified. So kind of understanding what simplifying means. So two separate fractions is not simplified, but if I can combine them together with a common denominator and have one quantity in fraction form in the end, then it's a simplified problem. So how could I combine those two fractions together?
You can turn the minus a into negative AH over H.
Yeah, common denominator. The one on the left has an H, so that means that A needs to have an H as well. And sometimes I cheat. I just add the H on the bottom, add the H on the top, or really multiply the H on the bottom, multiply the H on the top. So I did that in purple here. And now when I combine them, I have a common denominator of H. And then you're just looking across the top and writing them together. So 2A minus little a times H. Peter, question?
I did it a little differently, and I just don't know if my way like works at all.
What'd you do?
So back at where it says 2a is equal to a plus b h, I distributed the h, and then I subtracted the ah and then divided by h.
Ooh, I like that too.
Does that work?
Well, let's see. What did you get?
I got the same answer.
Yeah, but you didn't have to get a common denominator, right?
Yeah.
Yeah, that's nice. It was already there for you. So here would be another way. So Peter recognized that you could distribute the h through, and then you don't have a common denominator to worry about. Evan, do you have a question?
Yeah, I just wanted to ask, could you go back to 6 for a second?
Yeah, yes, I will, yeah. Give me 30 more seconds and I'll go back to it.
Okay, thank you.
You're welcome. So you can kind of see two different approaches to this. And again, like math, there isn't just one direct way to solve an equation. There might be one right answer, but you can still approach it in a couple of different ways, and both of them are correct. And like Peter's way, you don't have to get a common denominator. So if you kind of thought about distributing the h through, then you didn't have to worry about that denominator. Any questions on this problem? And then Evan, I'm going to go back up to number 6 for you. Okay, so if we travel back to 6, looking at this problem, Did you have a specific question on number 6, or you just wanted to see it again, Evan?
No, I just wanted to see it. Thank you.
Yep, no problem. So we got the 9 root x by itself, squared both sides, did some FOILing, and then some factoring, and we were able to solve. We have to check that solution. All of these you really should be doing a quick check. Some of them are a little harder to do mentally, so you might need to plug them in your calculator to make sure it works. The great thing about solving for x is that every solution you can check anytime you solve for x, because you're getting an answer that replaces the x in your equation, and you can always check that answer. All right, questions? So we're going to go over some interval notation, and then I think we're going to solve 2 inequalities. One I think is an absolute value inequality. Well, 2 absolute value inequalities, actually. So in your notes, chapter P, we're getting to the very end of chapter P. Yesterday, we kind of ended class with doing a little review of solving inequalities. And we solved 2 linear inequalities just by getting x by itself. And then we wrote our answer in inequality form. So we have that inequality x is less than or equal to 2 for the first one, and then the second one we had the compound inequality, -2 is less than x, which is less than or equal to 5. So we're going to look at interval notation and see if we can take that inequality form and write it as an interval. When we're writing things as an interval, you have to remember that the number on the left is the smaller number, the one on the right is the larger number, because numbers go from least to greatest. The other thing, if you're looking down this list, there's brackets and parentheses. And just a little refresher with a bracket versus a parenthesis. Does anybody remember the difference between having a bracket around a number versus a parenthesis around a number for interval notation? Peter?
A bracket includes the number and the parentheses doesn't.
Nice. Sorry, that's a little sloppy. So the bracket includes the number. That number is part of the answer. The parentheses does not. So a bracket is equivalent to a closed circle. A parenthesis is equivalent to an open circle. Or you could say if it includes equals to, then it's a bracket. If it's just less than or greater than, then it's a parenthesis. So closed circle, bracket, equal to, open circle, parentheses, less than or greater than. And then just a little refresher with the A and the B. Oops. This one is smaller. A is always your smaller number, B is the bigger number. So numbers increase from left to right. So we're going to just kind of look at this notation and think about what the inequality would look like so that you can kind of understand how an inequality pairs with interval notation. So the first one, we have bracket A comma B. So that's our notation. We're going to write it in inequality form so that we can start translating our inequalities to be interval notation. So if my inequality said A is less than or equal to X, which is less than or equal to B, that would correspond with the interval notation of the brackets around A and B. So to me, interval notation is actually easier because it takes the X and the symbols out of the problem. And now I just have brackets around A and B. We're also going to just get a little picture of the graph so you can kind of see what the graph would look like, because whenever you solve an inequality, your answer is a graph form. And I'm not going to make my graph fancy, just a little number line. Here's A, here's B. my answer or my graph would be in between A and B. And I'm going to put actually little brackets around them instead of using closed circles. So on the number line now, we're no longer going to be an open circle versus a closed circle. We're going to place the brackets or the parentheses on the number line as well. So that's what our graph would look like. So looking at the next one, I'm going to go through these. I'll probably get a little faster as we work down so you kind of get the idea. The only difference from the first one with the brackets to the second one of the parentheses is my inequality has just less than symbols. I don't have equal to anymore because those are parentheses. And Peter said parentheses means it doesn't include the number. Well, that's what less than means as well. And then make yourself a little graph. Place A and B there. But this time I'm going to put parentheses on my graph. So that interval notation is saying that my graph goes from A up and to B, or up to B. That's why you're shading in the middle, because my solution is in between those values starting at A, moving up to B, and that's it. So, Darby, do you think you could write the third one in interval notation?
Yeah, it would be, the inequality would be A is greater than or equal to X, which is just greater than B.
And yeah,
you wouldn't have the equal to sign.
Right, yes. And you just
and
had
then
and then what would the graph say?
And then the graph would have A and B, and on one side it would be a bracket, and on the other side it would be a parenthesis.
Nice, very good. Good. So as she said, bracket with the A, parenthesis with the B, still in between. All right, so kind of continuing down, as I said, I'm going to go a little faster here. So looking at the next one, I can see that it's opposite of what Darby just told us. So less than with the A, equal to with the B, because the bracket is next to B. Make your little graph, place an A and a B, parenthesis with the A, bracket with the B, still in between. So those are the four options where we would be shading in between two numbers. If you look at the next four, you can see there's infinity signs here. Does anybody know how you would write bracket A to infinity as an inequality? Peter, how would that get written as an inequality?
It would be A is less than or equal to X, which is
Right.
less than infinity.
And I'm just going to flip it around and write the X on the left, but what you said was not wrong at all. So I'm just going to say X is greater than or equal to A. So he said A is less than or equal to X. I just flipped it around because it goes to infinity. So my solution is bigger than that number. So if we look at that graphically, you just have A. We don't have anything else. A bracket with A, and then my solution is bigger than that number. And it goes to infinity. Notice there's a parenthesis with infinity, and that's because we don't know what infinity is. We just know it's a big number. So I can't say it's equal to it. So that's why there's always a parenthesis next to the infinity. See if you can fill out the rest of the ones underneath, so those next three problems. The only difference would be just greater than A instead of greater than or equal to. So try and complete those next three. So for negative infinity up to b, including b, how would that interval, or sorry, how would that inequality look? Kaden, do you know what that inequality would look like for negative infinity up to b?
B is less than or equal to X.
So if I wanted the x on the left side, that would say x is,
Greater than or equal to B.
you're close. So if I think about this as a graph, over here is negative infinity, and right here is b. So this is saying it's going from negative infinity up to b. How do your answers compare to b? Are they bigger than b or less than b?
Less than.
Less than. So we're going to take this and make it less than b. So it's kind of the opposite of the two above problems, the two intervals above this. So this time x is less than b because it's starting at negative infinity. So it's going to be smaller than b. And then it stops at b. And then I would just have x is less than instead of less than and equal to for the one underneath it. So just kind of making sure you've got that negative infinity that's smaller than b. And then the last one is negative infinity to positive infinity. What's that mean? Cole, what does negative infinity to positive infinity mean?
There's infinite answers.
Yeah, there's infinite answers. Last year, you may have written it with that all real number. Every answer. You may have seen it as negative infinity is less than x, which is less than infinity. We could have written it as all real numbers, but everything's an answer. So I don't have an a and a b on here because it's the whole number line. It doesn't stop at a value. It just goes on forever. And there are some graphs that go on forever that would have a domain of negative infinity to positive infinity. Questions? Evan, do you have a question? Okay. So we're going to look at the...
No, sorry. No, I don't.
Okay, I'm sorry. Okay, we're going to skip the graphing. As I said, we're going to do graphing with the calculator on Monday. We're going to go to example 3, and we're going to solve this inequality algebraically. And notice it's an absolute value. So thinking about absolute value and what we've done with solving equations, we know that we've got to isolate the absolute value. So I'm going to isolate the absolute value by first taking that 3 to the other side. Always need to get the absolute value by itself, the square root by itself, the quantity squared by itself, and that's consistent with equations and inequalities. Darby, how would you solve an inequality equation, which is now an inequality, or an absolute value equation, or an absolute value inequality? What do we do to get rid of those bars?
Wouldn't you would have to have two equations. So the one would be x plus 4 is greater than 14.
Good.
And then the other one would be x plus 4 is greater than negative 14.
And you are so close.
Would you switch the sign?
You would.
So it would be less than negative 14.
Right, and the reason we flipped that sign is because we're applying an inequality. We have an inequality, we're applying a negative, and anytime you apply a negative in an inequality, you got to flip the direction of the sign. So then I can solve this little problem here, subtracting 4, subtracting 4. So if x is greater than 10, x is less than negative 18. I'm going to put this on a graph so that you can kind of understand what it looks like, because sometimes having the graph, having a visual, helps us then write this as interval notation. So x is greater than 10 and x is less than negative 18. So on my line, here's 10, down here is negative 18. I'm not putting all the little tick marks in between. We're above that. We're beyond placing all those numbers. X is greater than 10 says parenthesis at 10, bigger than 10. X is less than negative 18 says parentheses with negative 18, less than negative 18. How would you write this in interval notation? So look at the graph. How would I take that and write it as interval notation?
Would that be negative infinity, like parentheses around negative infinity and 18, and then parentheses around 10 and positive infinity?
Nice, Jack. So you have two intervals. I have to explain the bottom interval and I have to explain the top interval. Because there are two intervals in our solution, we put a little u in between them. This guy is like saying together, both of them are the solution. It actually means in union with. Once you start taking college math classes, we use a lot of different symbols as shorthand to write different things. That u needs to be there. They're together. So both of those are the solutions. It's either less than negative 18, greater than 10. Any questions? Just really quickly, I'm not going to go through the whole problem here, but you could solve this last one as well algebraically, flipping the sign, and then solving it in the same format. When I divide by a negative, don't forget you've got to re-flip the sign. So I have x is greater than negative 2, and then x is less than 3. And I know I went through that quickly. Here's negative 2, here's 3, bigger than negative 2, less than 3. This one's shaded in between, so I write my numbers next to each other because the answer is in between. So again, the worksheet really is, the ones that I have assigned for you are exactly like the warm-up that we did yesterday. I'll leave this up here. So the warm-up with like linear inequalities and solving them. And then there are some absolute value inequalities that ask you to solve them. It does ask you to graph them on a number line, and the number line's there just to kind of help you take an inequality and place it into that interval notation. Have a fantastic weekend. The homework is not due till Tuesday. We're going to do graph and calculator stuff on Monday. Any questions? Have a great day.
Thank
Have a
you.
great
You
weekend.
too.
Thanks.
Bye, Miss Kane.
See you later.